Hello, and welcome to the brief video lesson on stars, stellar motions. In terms of a human lifetime, stars appear static on the night sky. That's why we call these fixed stars. But in truth, they're moving. If you look at the position of the Orion constellation when you were born and at the end of your life, you will notice that the stars are in the same spot. So we think that they don't really have a lot of motion, but the truth is they do. The sun, the moon, the planets, comets, asteroids, those all move. We see them because they're so close to us. But the stars are so distant, we don't see the motions over a course of our lifetime. For the most part, there are a few stars that break that exception. However, they do, and we can measure this movement. So this video will talk a little bit more about stellar motions, and it'll introduce some topics as an overview. So for further understanding of those topics, please consult those individual video lessons, such as radial velocity and proper motion. So the motions of stars. Stellar motion is divided into specific parts. The first one we'll discuss is radial motion, which is also outlined here as radial velocity. That is the fore and aft movement of a star relative to our position. Is it getting closer to us? Is it getting further away from us? That is radial velocity, the fore and aft motion. This is measured through something called spectroscopy, where you take the light of a star and you can break it out. You break it out in the form of a rainbow. And in this rainbow, you can see it shift from where it should be to where it really is. And this differential will tell you if it's coming closer to you or if it's moving away from you. This is called the Doppler shift. Proper motion is the motion that we can see on the night sky that appears to be like a left-right motion or an up and down. Maybe it's changing in its right ascension, which remember from another lesson is the left-right motion on the sky, or declination, its north-south position. That motion that we see is called proper motion. When you combine the two, proper motion and radial velocity, you get what's called true space motion. Remember, space is 3D. Sometimes it looks like everything is on a flat surface, but in reality, it is 3D, and therefore the true space motion gives us the combination of what is really doing on the night sky. So proper motion, when we look here, I want to compare the two to really differentiate it in our mind. We have two stars here relative to the sun, and the proper motion of those stars which are moving up on the screen is what we will see on the night sky. If we look here, in the case of this star that I'm circling, it is moving only towards us, then we're not going to see any proper motion. That gets into radial motion, which we'll talk about here in just a second. In the case of this star here, we can see a large proper motion if it's got a lot of speed to it, or if it's relatively close to us, we'll see that movement more pronounced on the night sky. Radial velocities, as we had mentioned, was based on the spectroscopy, the breaking of the light, and using the Doppler effect to measure its motion relative to us. So in this case, if we have a star that is moving closer to the sun, it becomes blue shifted. What it's doing is it's compressing wavelengths. In the shorter wavelengths, the bluer an object happens to be. If there were a star that was directly across from us, not moving towards us or away from us, we wouldn't see any shift at all. The spectra would stay the same as it should be in a steady state. It would show no radial velocity motion. If we see a star that's moving away from us, that movement away stretches these wavelengths and creates something towards the red side of the spectrum. The Doppler shift red means moving away from us, a longer wavelength. So when we look at the example on the right here, you can take a proper motion of the Alpha Centauri system. You can combine it with the radial velocity, is it moving away or towards us or away from us, and that there gives you the true space motion. So these two combine to let you know what this is really doing over the course of the sky. In summary, we talked about just the basics of stellar motion. For more details of each, consult those video motions. But remember, we have movement that we see on the celestial sphere, that's proper motion, which is measured in degrees, minutes, and arc seconds, that kind of motion. And we have motion towards us or away from us, which is radial velocity. Combined in the two, we have the true space motion. Thank you for your attention. We look forward to seeing you on another brief video lesson. Take care.